We have three technologies that are new in the marketplace. Two of them are centered around what's called nanotechnologies. They're involved with oxides that are a millionth of a millimeter in size. So these are about 5 to 7 nanos. Nanoscience is starting to really be on the forefront. I read something recently where they're able to take a product that looks very much like superglue, and through nanoscience, they're able to have it blended together. It's 20 times stronger than Kevlar, and about a penny a pound in terms of the cost. So nanoscience is something that's on the front end of technologies, and we utilize them in our coatings. We have two coatings in particular that there is nothing quite like them at all in the marketplace. One of them is on the forefront of metals and oxidation. Next slide, please. Our first product is called Activa. Activa is a product that we actually brought in from Europe. Our manufacturing partner is based out of Spain. A couple things with Activa. Activa uses titanium dioxide in a nanoparticulate form that goes onto a surface, and when it comes in contact with light, whether it's artificial or natural light, it actually activates a titanium dioxide nanoparticulate, and the offshoot of that is reverse photosynthesis, where it actually acts as an antimicrobial surface, deodorizing surface, so it removes volatile organic carbons out of the air, odors and smell. It's self-cleaning, so you can actually put, if dirt or grime or mold or mildew or fungus are on the surface, they actually breaks them down at a molecular level and it's easily wiped away. It's air purifying. As I said, it actually destroys volatile organic carbons in the air, and biofilm destroying as well. It destroys bacteria, mold, mildew, funguses, and viruses as well. It's a completely passive system. Again, only utilizes light energy in doing this. This is not a new science. This science was actually invented by the Japanese back in 1968. Dr. Fujishima and Dr. Honda at the University of Tokyo invented this and created this science. So this is not something new. However, just in the last few years has it gotten to the point where we're able to put it into paints, into clear coats, into cement additives, into stuccos. Again, how it acts, how it's used is it takes light energy and actually energizes a TiO2. And you'll see on the bottom stage right, your left slide, you can see how it actually purifies the surface. Light comes in contact with the TiO2. It then energizes that surface. VOCs and odors, bacteria, germs, and funguses are destroyed again at the molecular level. The offshoots of that is deodorized air or sterilized air, a small microscopic amount of gypsum and water, as well as a very small amount of nitrogen is dispersed as well. This is, again, how the science of it works. Bill, if you'd hit the next part, we'll do the drop-ins as well. It's a natural process. It's completely safe. It's completely passive. There's no energy needed at all. The only thing that's needed is light energy. On the right, you'll see how it cleans surfaces. And this is in particular for go ahead. It is never consumed in the process, so provided it doesn't get worn away, it lasts forever. You'll see on the right side how it cleans a building. You probably know that the Capitol building in Washington, D.C. is currently being redone and renovated and restored. The reason why that is because pollution has gotten into the concrete structure and the stone structure of the Capitol building and it destroyed it. This product was made and brought to market particularly for that reason alone. It was brought through what's called the Picata project in Europe, where the European countries got together and said, our pollution, our diesel fuel in the cars are destroying our monuments. How can we fix that? We heard that the Japanese have got this solved, and therefore this product line came out. That's actually the genesis of this whole entire product. Along and with that is the product is also used within a healthcare setting to destroy, again, those bacteria, mold, mildew, viruses, and fungus as well on the surface. We just completed a study with the largest emergency room and operating room in Barcelona. The product worked extremely well, and we've taken it and blended it actually with silver nanoparticulates. Everybody knows that silver is a natural antimicrobial, so we have a 1-2 punch to really attack the bacteria, the mold, the mildew, the funguses, and the viruses. Next slide, please. This will tell you how it's used and for bacteria and virus inhibition. When you've got H1N1, SARS, and Ebola, those are what's called bacteriophages. Those bacteria, or those viruses, live and exist on bacteria. They actually take themselves and hook themselves into the bacterial organism, and that's how they replicate and grow. Plain and simply, you do away with the bacteria, you do away with the viruses. That's how this process works. So we're not a biocide. We're not something that's going to require an EPA number, but actually we're something that takes that bacteria, neutralizes it, and kills it. It's akin to putting you into a bank vault. You could probably live for a very short period of time, but you're robbed of energy and nutrients, and eventually you would die. That's essentially how this works on the bacteria, the mold, the mildew, and the fungus. Yes, sir?
Does it work with artificial light?
Yes, it works on artificial light. However, it has to be something on the red spectrum. LED lights, it does not work very well on because they're not on the red spectrum unless you get LED grower bulbs. That's the one caveat. But natural light, as well as lights, these are just incandescent bulbs for the most part in here. It works very, very well. Next slide, please. And do one more for the drop-in. You'll see these are a couple of trial pictures that we're doing. The two on the left are at a luxury hotel currently in the Chicago area. You'll see the limestone structure where the treated and not treated area is. That's after just 2 months. This was out without power washing the surface and how it cleaned it. Below you'll see some granite stairs that are along that hotel. And you can see where we've treated it and where it's not treated, where the sun has hit it and it's completely cleaned it. And the last one on the right is actually out of Europe. It's out of Europe or England. And you'll see where we treated a roadside sign there. On the left side, it was not treated. On the right side, it was. And after 3 years, the product is still working. Again, is not consumed in the process and is a self-cleaning surface. Any other questions at all about Activa? Again, we've got everything from cement additives to paints to silver and Activa, as well as clear coats and even keeping glass clean too. We cause what's called a sheeting action, which actually self-cleans the glass. And we've got all those available for solar panels also. The next product we have is called Barrier Coat. This is a lightweight insulative coating that we use ceramic beads. If you look at them underneath the microscope, they look like little tiny donuts. And those ceramic beads actually insulate or form a barrier between temperature differences. So for instance, if you have a wall where on one side of the wall it's a very warm area, you're talking about 200 degrees, and on the other side you want to keep that area around 80 or 65 or 70, you apply barrier coat on the side of the wall where you've got a high temperature, and it will keep that heat from transferring from the high temp room into the lower temp room. There's no need to shut down in this process. We've actually taken Activa and we've blended along with our ceramic beads, and we have a self-cleaning insulative coating there as well. This also causes or reduces the condensation that can form below carrier decks in particular. It's got a long life. We have a 10-year warranty on the product. It works between minus 35 degrees to 450 degrees Fahrenheit. It is tintable, so right now ours is sold in white, but you can go ahead and tint it for any color that you may need. And again, it conceals temperatures and inhibits condensation. Next slide, please. Again, some of the key things with it: heat and cold temp barrier. It can be applied to roofs, decks, bulkheads, ceilings, bilges, tanks. Also, the low flame spread, it's of 5, so it will not carry a flame also. So we don't have to worry about, we have a ASTM E84 test, and again, we will not carry a flame. Okay? And our last product that we've got, again, this is along the nanoscience, is what we call BTR. Yes, sir. As far as the cost is concerned, the cost on it is going to range around $35 a gallon, and it's sold in 5-gallon pails. So really right in line with what most paints are, but you've got a insulative barrier paint. The BTR product, this is actually a nanoscience, and this will really make you think I've got a third eye. We have a professor or an inventor whose wife invented a blend of oxides that go in what's called a sol gel. These are two different types of solvents that are applied on the metal. And they found out that when they apply these three different types of nanoparticulate oxides on the metal, it forms a barrier and takes carbon steel and makes it as impervious to rust as stainless steel. They've taken stainless steel plates. Those stainless steel plates have currently been in salt water at 180 degrees for 5 years with electrical charge going through them and show virtually no oxidation or peeling or discoloration. This goes on at less than half a micron in thickness. It causes a surface barrier that is as tough and as hard as the steel surface it is protecting. It also insulates against electrical shock, not greatly because it's such a thin barrier, but it will add some insulation, and we're in the process of looking at doing radiation hardening insulation tests as well. These are blended and put onto the surface. They are heated briefly, and it forms a permanent barrier. These surfaces are weldable, they're stampable, they're paintable, and the product lasts, and it lasts forever. It's never consumed in the process. Kind of give you a little bit of breakdown of how it works. On the right side, you'll see these oxides and how they're put in. Those are what's called cationic oxides. They have a positive charge in them. They, kind of like two positive sides of a magnet, they repel each other just to a certain distance. Then there's this weird, funky thing called van der Waals principle that takes over. It's just a specific amount of distance that these will repel to each other. And within those microscopic crevices, water filters into. Now, water, as we know it, typically causes oxidation. However, because of these cationic oxides have such a different electrical pull to them, it actually changes the water from being a positive influence on oxidation to a negative influence on oxidation. Really important, especially if the surface is painted, and if it gets scratched, some of the paint comes off of it, water will filter in there, and actually water will keep that surface from rusting or oxidizing. Next one, please. 4 different types of corrosion that we guard against. You've got your general corrosion that we've seen everywhere. You've got your localized corrosion, where you have a passive layer. Pitting corrosion and crevice corrosion, as far as the military is concerned, is the most important one because they're the hardest ones to pick up on. Pitting corrosion is typically at a microscopic level, and crevice corrosion will be underneath a washer or a gasket and will not be seen or perceived until you have failure. We protect against all 4. We also work on all types of metals. We go everywhere, again, from carbon steel to aluminum to stainless to tin up to alloys. Last one, please. These are 2 coupons that we did on stainless steel 316 slides that were put into salt water. Again, this was for 3 months. You'll see the one on the right was coated, the one on the left was not. Plain and simply, after 3 months, you can see how the peeling and the corrosion is taking place on the stainless where it's not on the right side. We also protect against corrosion on pHs from about 3 to 11, so most acids we will protect against corrosion on those as well. Again, this goes on at half a micron, so about 2 molecules stacked up on top of one another in terms of thickness. Bendable, stampable, weldable, all of those are with us. This is a brand new technology, just patented. The patent is just completed, and we are in the process of coming to market with this right now. Okay. Any questions? Yes, sir. It's applied through a dipping process and then a heating or annealing process at about 350 degrees centigrade, so about 700 degrees.
If we could use the microphone for the questions. We are recording this, so
okay.
If you're talking to the mic, then...
We'll get it. Okay, the question was, how is it applied? Yes, sir.
Do you have an R value for your barrier?
R value for the barrier is around 20 to 24, but that's a little misleading only because when people think of R barriers, they think about foam insulation, Owens Corning type of fiberglass insulation. It's kind of hard to quantify it because we instead of taking the heat or the cold and insulating or absorbing it, what we do is we take the heat and the cold and we disperse it along the substrate, along the barrier. So it's a little weird to put an exact R value like we think of in a building trade. You could say it's 20 to 24, but in reality, it's kind of a misnomer. That doesn't totally explain it, but that's about the best we can do. Any other questions?
What are your plans for approaching the aircraft industry with this product?
With the BTR in particular, yes. We've sent some preliminary information down to Boeing. We've also approached some of the larger primes. They've all given pushback to go down to the base guys. So Ryerson Steel, Raytheon said go ahead and contact Nucor, Alcoa. So that's our plans for it. Is we're meeting with the Boeings and the Raytheons, Lockheed Martins of the world. They're giving us push down to the base suppliers of the metals and the alloys. So it's kind of a two-prong approach right now, and I so much appreciate what the gentleman before me was saying. It's sort of a cry in the wilderness. We sent out information to the Naval Research Lab. Obviously, they deal with corrosion all the time. We think we've got a much better mousetrap than galvanization and zinc oxide in terms of our coatings. But it's fallen into the abyss. So at this point, it's a matter of follow-up and work and perseverance to get through it. So sort of a rounded way, that's how we're going after it.